Okay, so today, the last part of 1.5, the last section in this chapter, we will have our chapter text next week, is proofs. So we have to make, in this one, it says show that the following statement is true by transforming the left to look like the right. Okay, so it says left look like right. Most of them today, I think they all say make the left look like the right. Okay, so that means we can't touch this side. I personally, I'm going to tell you, you have to do what with all these equal signs? Line them up, right? So if you're working on this side and it has to get bigger and smaller, is that going to be hard to do? Yeah? So a lot of times when it tells me to make the left look like the right or the right look like the left, I put it so what I'm changing is on the right. So I would write this as the sine of theta equals the cosine of theta, tangent of theta. So that way I can get bigger and smaller over here and still keep these equal signs lined up. Okay? I do not have a problem with you doing that. So this side, you're going to know the answer. You know the answer to every single problem when it says prove or verify. Prove, verify, show that all means prove. Okay? You will follow these steps. You know the answer. I need to make this stuff look like this. I am not solving. Do you understand what I'm saying? So I cannot add, subtract, multiply, divide stuff over from each side. I am just manipulating this like we've been doing, like yesterday. You manipulated those things. But it's telling you you're going to get it down to what? Sine. Okay, so what do you want to do with cosine and tangent?
Tangent, sine over cosine.
So, you notice the first thing I did is I wrote my thetas. You will also notice that I don't write my thetas in my work, but then I write them in my final answer, unless I need my thetas. Okay? So I have cosine, and then I have sine over cosine. Remember when we did Gauss-Jordan elimination, I said you can't do your work in the matrices. It has to be out on the side. You can't do stuff like crossing out cosine. This is all nice and neat. We're big kids. Should we know that we can reduce cosine right now?
Yes.
Yes. We don't need to actually do it, do we? So we have sine on the right, and we have to put our theta back in. And what is it supposed to equal? Sine. So you bring this one down. You don't have to write this sine every single step, just at the beginning and at the end. And now, I'm done. I want everybody to show me I'm wrong. So I have to put this little square right here. If you notice in your textbook when you're going through any of the examples, that is not a square, that is a rectangle. They will have a rectangle at the end of every problem. In your pre-calc book, they had it there too, but it was in yellow and you didn't notice. Every problem that you do is actually a proof, even when you're solving it. But these are proofs, so this is like the mathematical equivalent of a mic drop. I did it, you proved me wrong.
So I need to do that?
Yep, every single time. So you need to line them up, and when you're done, you put a box.
Mic drop.
Mic drop.
On every
It's
problem.
pencil drop.
Every single problem.
Every single proof. And the words prove, show that, or verify all mean a proof. Got it?
Yep.
Okay, so you got all odds today, yeah? And they only give you one example, so I might want to give you another example, right? Okay. Secant. Okay, it's going to say make the left look like the right, so I'm going to write it the other, like, I'm going to flip them. Does that make sense? So cosecant of theta equals secant of theta over tangent of theta. Now, knowing what the answer is a good and a bad thing, because I know it needs to be cosecant at the end, but it also makes my brain do some things sometimes that it shouldn't be doing, because I know it is supposed to be that. So, in your brain, what is cosecant?
Sine.
So 1 over sine. Yes?
Yes.
So if I can get this to be 1 over sine, I can reciprocate it and have cosecant. Yes?
Yes.
Okay. So what do you guys think you might want to do with this?
I don't know, Miss May.
Well, what do I eventually have to get?
1 over sine.
So what do I need to do with these? Make them into what and what? Sines and cosines. If I've got to get here eventually, I got to do that over here, yes?
Yes.
Okay, so secant is what?
1 over
1 over cosine.
cosine. And then sine over cosine.
And then we have sine over cosine. See how I over-exaggerated that middle?
Yeah.
Okay. So now I would multiply by the reciprocal.
Yeah.
Now I'm going to do it this time, but next time I will just do it in my head. If you need to write it, you do it. So cosine over sine. And what does that give me? 1 over sine. And what does 1 over sine equal?
Secant.
Nope.
Cosecant.
Cosecant of theta. Cosecant of theta. The left has to look exactly, pencil drop. Okay, the left has to look exactly like the right. You can't write cosecant equals 1 over sine. Even though it does, this side does not exist in my world other than it's what it's going to end up to be. Make sense?
Yep.
Okay, I'll do one more. How far are we going? 91. Now, remember, you have all mathematical skills available to you. Factoring, multiplying, common denominators, all those things are going to come into play. You can't take a square root because that's something you do on both sides, right? But you could plug in the square root of 1 minus sine squared for cosine squared, yes. But you're not square rooting both sides. Could you multiply by conjugates? Top and bottom? Yeah. So all those mathematical things that we've ever used to manipulate an equation are available for us to use. How do I know when to use them? Proving problems over and over and over and over again. So what are you going to have to do? Prove them over and over and over. You are not going to be an expert today, but you're never going to be an expert if you don't ever do them. Got it? Okay, I said 91, so should we do 90? I would think that would be like the hardest one, right?
Yeah.
Okay, so cosine of theta. And evidently this time I'm going to work on this side. Cosine of theta times the quantity cosecant of theta plus tangent of theta equals cotangent of theta sine of theta. Oh, plus. Thank you. And that's another thing. Once you write it down, go back and verify that you wrote it down correctly. Because if I would have put times, it would have never worked. And I've been running in circles. Okay, so this time I guess I am going to make the left look like the right. So I don't know if you guys have noticed, but I've put my equal sign first every time anyway, right?
Yes.
So what do you want to do to that left-hand side? You guys want to change from sine and cosines?
Yeah.
Okay. Now, that won't always be the best move, but this assignment probably, if you don't know anything else to do, do that. But there's other ones that have like 2 conjugates there. What do you think you need to do? Multiply them, right?
Well,
Okay. What?
Couldn't we just make tangent into 1 over cotangent?
You could, but that doesn't give you cotangent.
No, would that make it easier?
Does it give you exactly cotangent?
Uh-oh.
No. So if it didn't give you cotangent and you don't see a path to getting cotangent, I'd probably go with sines and cosines because what am I distributing? Cosine. See how I'm picking up on those clues? Okay, so I'm going to have cosine times what? 1 over sine plus sine over cosine. So I will say to you from time to time, follow the math. So the math tells me either I add these two, then multiply, right? or I can what?
Multiply or distribute.
And then add. Okay, so which way do you guys want to do it?
Distribute first.
Why do you want to distribute?
Because the cosine is
The cosine and the cosine will reduce out, and you will have what? Sine. And when I do cosine times this, I'm going to have what? Cotangent, which is going to be cotangent. So will you be working some things in your head? Yes. You got to think. Somebody's like, I just didn't know what to do. No, you don't. You got to think. Okay, so then I will have cosine over sine plus sine. And it's okay to do what I did because we are all big kids and we know that's going to reduce. Yes?
Yeah.
Okay. But you didn't see me go from this to that. You got to show me. So now what?
You have cotangent
I have-
plus sine.
But now the thetas have to come back in?
Yeah.
Plus sine?
Equals cotangent plus sine.
And?
Fiend.
It could be a triangle. Sometimes you'll see triangles in books.
Yes, I like that one.
I had people go, I'm going to draw a hexagon. We'll go for it. That would be silly.
It'd be so annoying to do every time.
Yep. And then I've had people say they're going to do circles. Well, if you're going to do a circle, you got to do a good circle. And not many people draw circles as well as I do. So, I can't do an example of every single one. I can just say go for it.
I'll go for it. I'm sure you would love